Okay, in this demonstration we were looking again at a type 3 function, and we sketched time a quadratic divided by a quadratic. And what we can see straight away is, let's find out the y-intercept. Okay, this is when x equals 0, so it implies that y equals, we've got 0 squared minus 6 zeros plus 5 all over 0 plus 1 is 1 times 0 minus 3 is minus 3 reverse negative 5 over 3. So the y-intercept is at the 0 minus 5 over 3 coordinates. The x-intercept is when y equals 0. So this implies that 0 is equal to x squared minus 6x plus 5 all over x plus 1 x minus 3. And clearly again the denominator is dividing, so whichever method you use you're going to end up with 0 times that, and so 0 is equal to x squared minus 6x plus 5, which conveniently factorizes. And what we're looking for is two numbers that multiply to give you 5, that up to negative 6, and they are negative 1 and negative 5. This implies then that either x minus 1 is 0, so x is 1, or x minus 5 is 0, so x is 5. So that gives us two intercepts on the x-axis. Let's have a look at the vertical asymptote. And as ever, what we're looking for is when does the denominator have a value of 0. Well, it's already factorized, so either x plus 1 is 0, so x must be negative 1, or x minus 3 is 0, so x equals 3. Those are your vertical asymptotes. Horizontal asymptote. I think in this case, because we're going to be dividing lots of terms, it would be useful, I think, to rewrite the denominator in an expanded form. So x times x is x squared. We have minus 3x plus 1x, which is minus 2x, and then plus 1 times minus 3 is minus 3. And the reason doing that is because we are now going to divide all the terms by x squared. And again, the reason I'm doing this a little strangely is because I'm going to have a different colour. Just as we've done before. So divide by the power, the biggest degree, so it's x squared, x squared, x squared, x squared. Do that for all 6, and that's okay. That's still a valid statement. Now, x squared over x squared is 1. X over x squared gives you 1 over x, and then nothing happens here. Then x squared over x squared is 1, and then we're going to take 2 over x, and we're going to take away 3 over x squared. Now this is the point now where we're going to make x extremely big. So when x gets really big and goes off to infinity, y is going to go towards 1 minus 6 over the something really big is 0, plus 5 over something really big squared is 0, over 1 minus 0 minus 0 again, which implies that y is going to be equal to 1 for the horizontal asymptote. Okay, so now what we've got are the usual pieces of the puzzle, which can take us to a place now where we can start graphing. But bear in mind that we will have to do more thinking. Alright, so let's go with, I can see straight away that the horizontal asymptote is at y equals 1. And as I can't remember, it's minus 3 and 3 for the vertical asymptotes. Sorry, minus 1 and 3. Negative 1. And 1, 2, 3, somewhere down there somewhere would give us the 2 vertical asymptotes. And we've got 2 x-intercepts at 1 and 5. So x is 1, x is 5, and a y-intercept at negative 5/3. So, what does the graph look like? It must go through or touch the intercepts. It cannot cross the blue vertical asymptotes, but it can cross the horizontal. So let's have a look. We'll do what we did before, which is the x-y thing. Okay, so let's look at the critical values. When x is minus 1, we see an asymptote, so y is infinity. When x is 0, we have y is negative 5/3. When x is 1, we've got y is 0. X is 3, we have a blue asymptote, so infinite. And when x is 5, we again have a 0. So what we're going to do now is examine the pieces in between there. Now, what I'm going to do is I'm going to write down the original equation, but I'm going to use the factored forms of both the numerator and the denominator. Okay, and we can do that, and this will make things a little easier, I think. So let's go from left to right. When x is smaller than minus 1, so in other words, we're going to choose a negative number smaller than minus 1. So let's say minus 2. The first part here would be negative. This part here in this bracket would also be negative, so negative times negative would give a positive numerator. X is negative 2. The first brackets here are negative, and the second brackets are negative. Negative times negative is positive, therefore we have a positive y values. Alright. So now what we're going to do is going to go from minus 1, beg your pardon, to 0. The next section, let's choose a value, let's say negative 1/2, and examine what happens in these brackets. When it's negative 1/2, we have negative, times negative is positive. Denominator, first bracket, negative 1/2 plus 1, that's positive, times negative is negative. Next section, we're going to go between 0 and 1. Let's choose 1/2. Half. So let's look. If x is 1/2, the first bracket is negative, the second bracket is negative. That gives us a positive result. And if we have 1/2, the first bracket on the denominator is positive, and the second one is negative, so we have a negative result altogether. Let's go between 1 and 3. Let's say 2. Taking out the numerator, we're going to have 2 take away 1 is positive, 2 take away 5 is negative, so negative on the top. And we're looking when x is 2, so that's positive first part, negative second. Negative and negative is positive. 3 to 5 is the next section. Let's have a look at y. Let's choose 4. 4 take away 1, positive. 4 take away 5 is negative. Positive, negative is negative. Choosing 4. 4 plus 1 is 5. 4 take away 3 is 1. Positive, 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 which again gives us a negative between 3 and 5. Let me just check that. Okay, yeah, okay. And next section is when x is bigger than 5. So when x is bigger than 5, let's say 6, we have numerator positive, positive, which is positive, denominator positive, positive, which is positive. So these are the results. Right, let me fill those in. So I've got positive, negative, negative, positive, negative, positive. And let's go from left to right and see what happens. We can see that to the left half we have everything is positive. Now everything is positive, and we're going to come down here. Definitely can't cross the blue one, and if we could cross the red one, the algebra would have told us. Next section is negative between -1 and 0. So it's negative between -1 and 0, which is from here to here, and it must go through that point. So I'm guessing it looks like that because you can't cross the asymptote. From 0 to 1, what we have is negative also. So that, I think we'll do that. Again, bear in mind that this is a sketch, so we've got negative there, and between 1 and 3 it's positive. So I'm thinking that it's going to go up somehow up there, like an S shape. Now mine's not to scale, so yours might be a better drawing than mine. And finally, between 3 and 5 it's negative. So we're looking at that. It must cross through 5 because at 5 it's positive. So that's what it looks like. What I'm going to do is I'm just going to color code them so that you can see them. That's it. Next bit is blue, which is that bit. Next bit is green, which is that little bit there. Next bit is pink or purple, which is now between 1 and 3, which is all of that. And then let me choose a couple more colors. Let's go orange, which is that section. And finally, we've had yellow, we've had blue. Let's go with, I don't know what color that is. Blood. Okay, that's it. Thank you very much.